If you check the first compound, you can see the central metal ion, right? Cu2 plus, correct? Also you can see ligands, right? Correct? Now in the presence of ligands, what happened to the central metal ion? We know the degeneracy of the d orbital will lose, correct? As a result, you will be getting a set of new 2 orbitals, correct? Now, if unpaired electron is present, then what will happen? Electron will absorb light energy and excite to the higher energy level. You remember, right? See, when ligands approach the central metal ion, the degeneracy of the d orbital of the central metal ion will be lost. As a result, what you will get? You will be getting a set of new 2 orbitals like this. Now, if unpaired electron is present, it will absorb light energy and excite to the higher set of orbitals, correct, right? We call it as DD transition. So for a coordination compound to be colored, you have to check presence of ligands are there or not. Here you can see ligand is present, correct? So definitely what happened? CFT, crystal field splitting happens. Then you have to check unpaired electron is there or not. Of course, Cu2 plus have unpaired electron. So definitely what will happen? That compound will have color due to the DD transition. You understand? In the hydrated form, water molecule act as ligand and surround the Cu2 plus ion. These water molecules split the d orbitals of Cu2 plus, allowing what? DD transition of electrons. Hope you understand. This absorption causes the compound to appear as blue color. Regarding copper sulfate, there is no water molecule, right? No ligand, no crystal field splitting, no DD transition, so no color. Okay, now you can check the statement answer. In copper sulfate, okay, copper sulfate pentahydrate, water acts as ligand. As a result, it causes crystal field splitting. Hence, DD transition is possible in copper sulfate pentahydrate and shows color. In the anhydrous copper sulfate, which means there is no water, due to the absence of water ligand, crystal field splitting is not possible and hence no color. Hope you understand.